Good morning, students. In the previous lecture, we have seen what is motion, what is uniform motion, what is non-uniform motion, concept of distance, concept of displacement, concept of scalar, concept of vector, speed, velocity, acceleration, positive acceleration, negative acceleration. Today we are going to discuss distance time graph for uniform motion, distance time graph for non-uniform motion, velocity time graph for uniform velocity, velocity time graph for uniform acceleration, equation of motion using graphical method, etc. So the first topic is distance time graph for uniform motion. So here one table is given. Here time is in second, distance is in meter. At time t is equal to 0, distance is 0. At time t is equal to 10 seconds, distance is 15 meter. At time t equal to 20 seconds, distance is 30 meter. 30 seconds, 45 meter. At 45 seconds, distance is 60 meter. At 50 seconds, distance is 75 meter. At 60 seconds, distance is 90 meter. And at t is equal to 70 seconds, distance is 105 meter. So here is one table is given. On the basis of this table, you have to plot the graph. So I will tell you how to plot a graph on the basis of given table. This is x-axis, this is y-axis. Always remember, time is taken on x-axis. Here will be time. Time is in second. Time is in second. Y-axis, distance. On y-axis, we have to take distance. Distance is in meter. So in bracket, we have to write m meter. This will be the origin of C. T is equal to 0 second. Right here 0, origin of 0. This is 10 second. This is at here 20. Here will be 30. Here will be 40. 50, 60 and 70. Okay. Actually, we have to take the equal interval. Okay. Here is the interval of 10 minus 0, that is 10 seconds. 20 minus 10, that is 10 seconds. 30 minus 20, 10 seconds. 40 minus 30, 10 seconds. 50 minus 40 is equal to 10 seconds. 60 minus 50 is equal to 10 seconds. 70 minus 60, that is equal to 10 seconds. So interval should be equal. Again, on this we have to take distance. So distance interval should be equal. So here we have to take 15. Take here 15, 30, 45. So take here, that is 15, 30. Take some small distance. Here will be 15. Here will be 30, 45, 60, 75, 90, 105. Okay. So at t is equal to 0 second, distance is 0. T is equal to 0 second, distance is 0. So this t is equal to 10 second. T is equal to 10 second. Distance is 50. This one. T is equal to 20 second. Distance is 30. 20 second, distance 30. T is equal to 30 second. Distance is 45. 30 second. $45. Then 40 second, distance is 60. This one. 50 second, distance 75. 50 second, 75. 60 second, distance is 90. And t is equal to 70 second, distance is 105. So now you have to join all the points. So this is the graph of distance time. This is distance time graph for uniform motion. Now we have to plot distance time graph for non-uniform motion. So again, time we will take on x-axis, distance we have to take on y-axis. As I have told you, time is always taken on x-axis. This is the distance time graph for non-uniform motion. Non-uniform motion is what? An object moves unequal distance in equal time interval. So, see here. Here will be time in second. Time in second. Okay. Interval should be equal. One thing I want to tell you, in the graph you have to do the scaling. Scaling means what? Here you have to write, space is not there, so I am erasing this one. See, that is scale. Scale means what? You have to measure, otherwise this graph is wrong. X axis suppose this is 1 centimeter. X axis 1 centimeter is equal to 10 second. 10 second. Here on y axis 1 centimeter is equal to 15. This is the interval of 15. 30 minus 15, that will be equal to 15. 45 minus 30, that will be equal to 15. So on y axis 1 centimeter is equal to 15 meter. 15 meter. Okay. So now come to this graph. Time is in second. Distance is in meter. So here will be distance. Distance is in meter. Meter m. Origin O or 0. Time interval is of 5 minus 0, 5 second. 10 minus 5, 5 second. 15 minus 10, 5 second. It means interval is of 5 second. So here will be 5, 10, 15, 20, 25, 30, 35. Okay. See, here is the interval 7 minus 0, that is 7. 12 minus 7, that is 5. Here is the interval of 7 is a 5. So you have to take equal interval. It means we will take interval of 10, 10, 20, 30, 40. Understood? Don't take the interval of 7, 12, 20, 30, 41, 50, 58. So you have to always remember interval should be equal. So we can't take 7, 12, 20, 30, 41, 50, 58. Okay. So here we will take interval of 10 so that all data will become. So here I am taking 10, 20, 30, 40, 50, 60. X axis and y axis. See, at t is equal to 0 second, distance is equal to 0. T is equal to 0, distance is equal to 0. This will be the point. Okay. T is equal to 5 second, distance is equal to 7 meter. See, 5 second, this is 5 second, draw the perpendicular line. This is 10, this is 10. Here, maybe here will be 7, below 10 will be 7. Time is equal to 10 second. This is 12. Time is equal to 10 second. Distance is 12. Here is 10. Here will be in between 20 and 10. Here will be 15, 12. Maybe here just above 10. Here will be 12. At 50 second, 15 second, Distance is 20 meter. 15 seconds. You have to plot this graph on the graph paper. Okay, so if you will make on the graph paper, then your graph will be very neat and clean. 15 seconds. 20. Here will be 20. 20 seconds. 30. 20 seconds. 20 seconds. 30. 25 seconds. 41. 25 seconds. 41. See, this is the 40, 41 maybe, just above 40, 41. 30 seconds, 50. 30 seconds. 50. So here will be 50. 35 seconds, 58. 35 seconds. 58. Here will be 60. 58, just below 60. Here will be 58. So if you meet all the points, so this is the graph of non-uniform motion. See, this is not a straight line. This is not a straight line. This is a straight line. It means the difference between the graph of uniform motion and non-uniform motion. What is different? Difference is, in uniform motion, graph is a straight line, but in case of non-uniform motion, graph is not a straight line. This is not a straight line. Okay. So this is the way how to plot a graph on the basis of given table. Understood? Now your next concept is velocity time graph for uniform velocity. So time is on x-axis, velocity is on y-axis. Understood? So one graph is given. This is the graph of uniform velocity. See, if first of all I want to tell you how to read the graph. A car is moving 60 km per hour. It means if I ask at t is equal to 0 hour, what is the velocity of a car? You will say 60. At time is equal to 1 hour, what is the velocity of the car? Again 60 km per hour. Since velocity is on y-axis, that is in km per hour. At t is equal to 3 hour, again what is the velocity of the car? Again this is 60 km per hour. At t is equal to 4 hour, what is the velocity of the car? Again this is 60 km per hour. At t is equal to 5 hour, again velocity of the car is 60 km per hour. Okay, it means velocity of the car is constant. There is no any change in the velocity. That's why this is uniform velocity. That is uniform velocity. So on the basis of this graph, what you have to do? You have to, with the help of graph, find the distance covered by the train between 2 and 4 hours. 2 and 4 hours. Here is the 2, here is the 4. So what you have to find? You have to find distance covered by a train between 2 and 4 hours. 2 hours is here. So draw a perpendicular line from 2. Here is a 4 hour. So always remember, in velocity time graph, this is the graph of velocity time graph. Here is the distance time graph, distance and time. So this is distance time graph. Here again, this is distance time graph. Listen here, I forget to write a scale. So you can write here a scale. X-axis like this. X-axis 1 centimeter is equal to here 5 seconds. On x-axis 1 centimeter is equal to 5 seconds. Understood? On y-axis you have to write 1 centimeter. 1 centimeter is equal to 10 meter. Understood? So I forget to write scale in this graph. Okay. So listen. So in velocity time graph, if you have to find the distance, then what you have to do? You have to find the corresponding area. In these questions, we have to find the distance covered by the train between 2 and 4 hours. 2 and 4 hours. Okay. So what I did, I plot a perpendicular line from 2 and from 4. So this area you have to find. So this is from here to here, this is 2, here to here, this is 4, right? So this interval will be equal to 4, here, from here to this is 4, here to here 2. So this interval will be equal to 4 minus 2, that will be equal to 2. This will be equal to 2. And this length, you can write your name A, B, C, D. So this is a rectangle, right? So if you find the area of rectangle A, B, C, D, it gives distance covered by a train between 2 and 4 seconds, 2 and 4 hours. Okay. So distance is equal to, distance is represented by S, is equal to area of the rectangle. Area of the rectangle means what? L into B. That will be equal to length. This is length. This is 60. That is 60 kilometer per hour into, this is B. So this will be equal to this length. From here to here is 4, here to is 2. So this distance will be equal to 4 minus 2. This will be equal to 2. 2 hours. Hours are cancels. This will be equal to 60 to the 120. 120 kilometer. It means distance covered by the train between 2 and 4 hours is equal to 120 kilometer. I hope you understood. Now next graph is velocity time graph for uniform acceleration. Okay. So time is in second, velocity is in meter per second. So again we have to plot the graph. This is the change in the velocity of a car in a specific time interval are given in the table. So I have told you how to plot a graph. This is 56, this is 56. X-axis, just a second. X-axis, this is y-axis, this is origin or 0. On x-axis, I have told you we have to take time. So here I will take time. Time is in second. On y-axis, rest of the thing, that is velocity. Velocity is in meter per second. Okay. Interval of time is 5 minus 0, 5 second. 10 minus 5, 5 second. 15 minus 10, 5 second. Similarly, this 5 second, 5 second. It means we will take here in time interval is of 5 second. Here is 5, here will be 10, 15, 20, 25, 30, 35, you can take 40 also, no problem. Here we have to check velocity interval is equal or not. 8 minus 0, 8. 16 minus 8, 16 minus 8, 8. 24 minus 16, it is 8. 32 minus 24, again 8. 40 minus 32, again 8. 48 minus 40, 8. 56 minus 48, that will be equal to 8. It means we can take interval of 8 meter per second. We can take interval of 8 meter per second. It means here we can write 8 meter per second. Here will be 16 meter per second. 24, here will be 32, 40, 48, 56. Okay. Now see scale. In the previous graph I forget to write scale, but this time I will write scale. X-axis. Suppose this is 1 centimeter. 1 centimeter is equal to, is the interval of 5 what? 5 second. 1 centimeter is equal to 5 second. Y-axis, 1 centimeter is equal to, this is 8 what? Meter per second. 1 centimeter is equal to 8 meter per second. Okay. Now see, t is equal to 0. Velocity is equal to 0 meter per second. T is equal to, here is t is equal to 0, here is t is equal to 5, here 10 and so on. Here is t is equal to 0 meter per second. Here t is equal to 8, t is equal to 16 and so on. 0, t is equal to 0, velocity is 0. It means this point. T is equal to 5 second, velocity is 8 meter per second. 5 second, velocity is this point. T is equal to 10 second, velocity is equal to 16 meter per second. 10, here is 10. Draw the perpendicular line from 10 and 16. Intersection point will be your point, required point. 15 second 24. 15 second 24. This will be the point. 20 second 32. 20 second 32. This will be the point. 25 second 40. 25 second 40. This point. This point. 30 second 48. 30 second 48. And you can take 35 second 56. I am not taking because I have written here. So I hope you understood. 35 second 50 seconds, this point will come here. So I am not taking this because I have written here. You have to meet all the points. Okay. So this is the graph of velocity time graph. And this is why this is called uniform acceleration, since see, from 5 seconds, from 0 to 5 seconds, velocity changes from 0 to 8. From again 5 to 10 seconds, 5 to 10, it means 5 seconds, velocity was 8 meter per second, and finally at 10 seconds, this became 16. So change in velocity 16 minus 8, that will be equal to 8 meter per second. Again, change in velocity in 10 to 15 seconds, 10 second to 15 seconds. 10 second, the velocity was 16, and at 15 seconds, it became 24. So change in velocity in 5 seconds, again 24 minus 16, that will be equal to again 8 meter per second. Again change in velocity from 15 second to 20 second, that is in 5 seconds, next 5 seconds, again the velocity became from 24 second to 32 second, again 32 minus 24, again 8 meter per second. That's why this is uniform acceleration. Change in velocity is 8 meter per second in 5 seconds. Again next in 5 seconds, change in velocity 8 meter per second. Next 5 seconds, change in velocity 8 meter per second. Next 5 seconds, change in velocity 8 meter per second. That's why it is called uniform acceleration. Okay. So if I ask, find the distance covered by the car between 10 to 20 seconds. If I ask from you, find the distance covered by the car between 10 second and 20 second. 10 second and 20 second. So what you have to do? First of all, you have to check. This is velocity time graph. Yes, this is velocity time graph. It means we have to find the respective area. This area. Draw the perpendicular from 10 and 20. So this is the required area. So if you find this area, it means you will find distance traveled by a car between 10 and 20 seconds. So this is the trapezium. There is two ways to find distance. This is the trapezium, okay? So you have to find the area. Suppose this is A, B, C, D. This is a quadrilateral trapezium. So what will be the answer? I will erase this. I am writing the questions here. So I have written here. So you have to find from the graph, find the distance covered by the car between 10 and 20 seconds. 10 and 20 seconds. So this area of trapezium A, B, C, D. You have to find, okay? So distance S is equal to area of trapezium. That will be equal to 1/2 into sum of parallel sides. Sum of parallel sides. This is the parallel. This AD and BC both are parallel. The sum of the parallel side. It means 1/2 into AD plus BC into height. So this is the height. This interval. This one height. So this will be equal to C. Here from 0 to 20. From here to here is 20 and here to here is 10. So this distance will be equal to 20 minus 10. That will be equal to 10. So this interval is of 10. Right here AB. First of all write AB. So 1/2 into AD plus BD. AD plus BC. AD, how much? AD is 16. This is 16. And BC is 32. Then it means right here 16 plus BC is equal to 32. AB, this one, this is the gap of 0 to 20. From here to 20, here to this 10. So if you subtract this one, then you will get this. This is 10. 10. This will be equal to 1/2 16 plus 22. That is 48 into 10. 2 1 the 2, 2 to the 4, 4 to the 8. This will be equal to 24 into 10. That will be equal to 240. This is the distance. Distance will be in meter because see, here is meter. Second will cancel out. So if you want to write with units, so you can write here. You can write here. See, you can write here like this. 1/2. 16 plus 32, that is 48 into 48. 48 what? 16 plus 48. This here you have to write meter meter per second into 10. 10 is what? AB. AB. This is the 10, right? This was a 10. So 10 was in second. So right here 10 second. 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 I am writing just simply S. Second. Second cancel. 2 1 the 2. 2. 2 to the 4. 4 to the 8. It means 24 into 10. Here is meter, so write here meter. This will be equal to 240 meter. So from the graph you can find distance covered by the car between 10 and 20 seconds. How much? This will that will be equal to 240 meter. How much? 240 meter. One more method is there to find the distance. You will find. I will not tell here. You will find, but I will tell you how you will find. So this area you have to find, okay? So you can also draw here to the perpendicular. A, B, C, D, right here, E. So you can find area of rectangle or area of square and plus area of triangle. This is the triangle, this is the rectangle or square. Okay? So if you add area of rectangle plus area of triangle, then again you will get 240. So this is the homework for you. You will find, and answer is 240 meter. Answer will be equal to 240 meter. So what you have to do? This is the area of rectangle. Length is equal to again 10. L is equal to 10. This is B. This will equal to 16. So if you find this area of rectangle or square A, B, E, D, this will be equal to 10. 10 into B is equal to, see, this distance. This distance is equal to 16. Okay? Plus, this is a triangle. This is a right angle triangle. So the area of right angle triangle is equal to 1 upon 2 into base. This is the base, or you can assume this is the base. Anyone take you can. 1 upon 2 into base. This is the base. So again base is, this distance will be equal to again 10 into height. This height. This will be equal to, see, 32. Here to here 32. And here to here is 16. So this distance will be equal to 32 minus 16. That will be equal to 16. 2 1 the 2. 2 8 the 16. This will be equal to 16 into 10. 160 plus 10 into it. That is 80. That is equal to 80. That will be equal to 0 to 240 again meter. Since second will be cancelled out. So meter will be there. So 240 meter. So there are two ways to find distance covered by a car between 10 and 20 seconds. Okay? From this graph. See, here is 10. Here is 240 meter per second. Again here is 240 meter per second. So answer will be same. So in the next lecture, I will explain equations of motion using graphical method. Okay? Thank you.